because they're both right, they're the same number.
Yeah.
And it just becomes PbO. So here's the difference, okay? If we have lead 4 oxide, okay, and let's write this out now. So you're going to write the formula here for lead 4 oxide. So remember just the formula. That's good. That's it. When you write out the name, okay, write lead with a, you know the Roman numeral for 4?
It's IV.
Very good.
Okay.
Yeah. And now,
Oxide.
excellent. Okay, that's it. You're done. That's the name of that formula. Okay, so when you look at this, how many atoms in lead 4 oxide?
6. No.
Okay, how many oxygens do we see?
2.
How many lead?
4.
No, there's no 4 there.
Oh, 3.
That's-
Because,
No. Okay, 3 is the total, isn't it?
yeah.
So there's 1 lead plus 2 oxygen altogether, like this. There it is.
Yeah.
1 lead, 2
Two,
oxygen. Okay. How about this one, though? Lead 2 oxide. How many atoms in that formula?
2 lead and 2 oxygen.
Oh, do you see a 2 there?
Oh, no.
No, there's just 1 lead
and 1
oxygen. Okay. So where did we find that? There it is. So just like we have only 1 magnesium and 1 sulfur, when the numbers match up, you only need 1 of each.
Oh, okay.
So that's why we have to say which lead it is, because even though both, maybe I'll just draw this very quickly. Okay, let's see. There we go. There's our lead. But this is a lead plus 2. There's our oxygen, which is minus 2. Okay. Here are pictures of lead 4 oxide versus lead 2 oxide. Okay. This has 3 atoms. This has
2.
2. That means these 2 molecules will have different weights. This is heavier. It's going to have a higher melting point. It's going to have different properties. It's actually a different thing. Even though they're both made of lead and oxygen, they're 2 different compounds. And the way we tell them apart is by putting the Roman numeral. So whenever you have one of those metals that has more than 1 valence listed in the periodic table, you have to say which one you have when you write the name. So here, they're telling us which one it is by giving us that little charge. Okay? Now, sometimes they don't tell us what it is. They show us what it is in the formula. Now, with this one, we could figure out if it was lead 2 or lead 4 by seeing how much oxygen does it need. Because we know every oxygen is worth
2
charges, and 2 oxygens means 2 times 2
is 4.
is 4. So that has to be lead 4. So we're going to do the same thing now going backwards with these ones. So we've got iron, which is multivalent, combining with, what's the F?
Fluorine.
And what is the charge on fluorine?
-1.
So just 1. But how many fluorines are in this compound?
3.
So what's the total negative charge?
4.
It's 3 times
1.
3 times 1 is?
3.
Bingo. Okay. So what you figured out here is that we have, okay, fluorine which is just a single minus, and our iron, weirdly named Fe, is a 3 plus. So when we write the name, we're going to say it's iron
3.
fluoride. Okay, so that's what you write down, iron 3 fluoride. Very good.
Why do you multiply it? Like, why didn't we multiply here, but you multiply here?
Okay, so here we're starting with the ion,
Mm-hmm.
and it's showing us the valence. And from that, we're making the formula. On this question number 2, we're working backwards from the formula. They're giving us the formula, and we're having to do the crisscross in reverse to figure out what was the valence on that.
So
These nonmetals, we can just look them up. They're always the same. But the metal, we have to figure it out by seeing how many of the nonmetals did it take.
Okay, so if you're creating them, you add, and if you're trying to figure it out, you multiply.
Let's do another couple of examples before we make a rule.
All right.
Okay?
All right.
So let's start with the next one. So
Mhm.
this Cu is right here. What's the element?
Copper.
And we can see it could be either a 1 or a 2.
Yeah.
Okay. So here copper is combined with,
Chlorine.
and the chlorine has a charge of,
1.
yeah, so only 1. How many chlorines?
2.
So it's 2 times the
Times-
charge of 1. So
Yeah.
total charge is,
2.
so what's the charge on the copper?
2.
Bingo. Okay. So you're going to write copper
2.
chloride. Okay. That was good. Next one. That's a weirdly named one. It is,
10.
yeah, tin. SN stands for tin.
All right.
Yeah. They're a little tricky sometimes. So
Mhm.
we've got tin, and we can see it could be a 2 or it could be a 4.
Mm-hmm.
So this tin is combined with,
Oxygen.
good, and the charge on oxygen is,
2.
ooh, and how many oxygens did it take?
2 times 2.
Which is?
4.
Excellent. So you're going to call this tin
4. Oxygen 2.
oxide.
Oxide,
Tin, yeah, so tin 4. Okay. One more for good luck.
All right.
Okay. PT down here.
Platinum.
You got it. Good job. Okay, so could be a 2, could be a 4. So it's platinum. Let's start by just writing the name platinum because we figured that out.
All right.
We can do this step by step. So platinum, and now we're going to figure out what the charge is. So what's it combining with here?
Sulfur.
And the charge on sulfur is?
2.
How many sulfurs did it take?
2.
So it's
2
2 times 2.
which is 4. And then sulfate.
Ah, sulfide.
Uh,
So when you're using one of these nonmetals, you always change the end of it to "ide." So
Okay.
these names, if it's, I can see all of these "ide," 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 "ide."
Mm.
And so that is almost always one of these elements.
Mm.
And now that you're kind of getting this, we're going to make it just a little harder.
All right.
Okay? I think you're doing okay with this. Let's do just a couple of these. And write the chemical formulas. I really like to write in the ions here, just because it's so much easier to write the formula if you see the ions.
Mm-hmm.
So they're telling us what the charge is on the metal. right?
Mm.
You have to when you write the name.
Yeah.
So iron we know is Fe, and they're saying iron 3, so that's 3 plus. Mixing it up with chloride,
Which is
Cl.
1.
Yeah, so Cl with a minus. When we crisscross them, we're going to have 1 iron and how many chlorines?
3.
Good. So copper with a charge of 1, Cu with a single plus, oxygen,
With another plus.
Ox-
No, 2.
2 minus, right? Plus and minus together to make the compound. So
Mhm.
we're going to crisscross them. How many copper?
2.
Good. How many oxygen?
1.
Excellent. How many atoms in total?
3.
Yeah.
Oh, I'm starting to get it now. It's something's clicking.
And sometimes it just takes sitting down. If it's not making sense,
Mhm.
I'm here, right?
Yeah.
Even after rugby, I'm still here.
Yeah.
Okay, so we're going to just take this on. I think you're okay. You do need to practice this, so
Mhm.
I would say finish this off. And the last little bit. Hey, Philip, we're almost done.
No, don't worry, I'm just going to listen to
You're
it.
going to learn some more chemistry? You miss having me as your teacher?
I actually do.
It's because I'm a marshmallow, right?
No.
Okay. Because I fed you marshmallows.
Yeah.
Okay. So now we're going to look at these polyatomic ions.
Mhm.
Now the way we think about these things, they're just a big chunk of atoms all stuck together, not because electrons move, but because they're sharing electrons.
Mhm.
So the easiest one to think of is hydrogen. Hydrogen only has 1 electron. It would really like to have 2. If it had 2, it would be just like helium, which is perfect.
Mm.
Okay, so it doesn't want to give up its 1 electron. So you're going to be a hydrogen atom, and your pencil is your electron.
All right.
Okay, I am also a hydrogen atom. This is my electron.
Mhm.
I'm not going to give you mine up. You're not going to give yours up. But what we can do is we'll share. Okay?
All right.
So right now we're sharing these 2 electrons.
Mhm.
We both have 2. Yay!
Yeah.
We're perfect.
Yeah.
Okay? But nobody's lost or gained.
Yeah.
This is not ions. This is a covalent molecule.
Mm.
And covalent molecules only form amongst nonmetals. They're the only ones that can share. Metals can't share electrons, only nonmetals can.
Okay.
And so when nonmetals all get together and they share electrons, they form compounds, and some of the compounds are then ions. Ugh. Okay, so all of these are nonmetals sharing electrons, but also having either an extra 1, 2, or even 3 electrons, or in this one wretched exception,
Mhm.
has lost an electron. So an ammonium polyatomic ion,
Mhm.
it's made of nitrogen, and the nitrogen has 4 hydrogens around it. So it's like, okay, we've got the nitrogen, and stuck to it, 4 hydrogens. And then floating around here, it's lost an electron somehow, and it has a positive charge.
Hmm.
Okay, how many atoms there?
Philip. I'm sorry.
That's all right. How many atoms?
4, because there's 4 hydrogen.
4 hydrogen. What about the guy in the middle?
Does that count?
It's a nitrogen atom.
Oh, okay, so 5.
5. So this polyatomic ion is made of 5 atoms.
Whew.
Mm-hmm.
All right.
Okay. So now, when we start to combine them, these guys mostly have different endings, right? They
Mhm.
say 8, 8, 8. Some of them say things like "ide," right? So you might have a nitrate and a nitride. The difference being, nitrate is nitrogen with 3 oxygens. Nitride is nitrogen with two oxygens.
Mhm.
Different